Rain1290 with you to bring you another risk analysis for thunderstorms, specifically strong to severe thunderstorm potential for July 12th to July 13th, 2025. So stick with me to the end of this video to actually see me identify the target zones and identify the thunderstorm hazards that would go along with this risk analysis. So without wasting any more time, let's get right into it. Okay, so just looking quickly at our surface pressure map. So we see this warm front represented by this red line with red semicircles. So this is the warm front that's at play for southern Quebec during this mid-afternoon to late afternoon period. So I think this will help promote at least isolated thunderstorm coverage, some of these strong to severe. And then in the case of July 13th, so this is progged for the morning of July 13th, but it will have more applications for the afternoon period than late morning. So you have this cold front that's also at play that would be moving to the northeast and affecting these broad regions here. Okay, so quickly evaluating how quickly temperatures are decreasing at the mid-altitude, so specifically at the 700 to 500 millibar altitude range. So we're really looking for these gray to greenish colors, or better, of course, and we're not seeing all that much. So this is at 5 p.m. today, July 12th, and we're not seeing all that much taking place in Eastern Ontario, much of the Northeast really, and Southern Quebec. So let's go 3 hours later, so one more time step forward, and we're still not seeing all that much into the late afternoon to early evening. So going into July 13th, which is the day mostly of concern, this is now pre-dawn, late morning, well, early morning, now late morning, and then going into the afternoon period of July 13th. And still not all that much taking place. So our mid-level lapse rates are pretty tame between July 12th and July 13th. So checking our low-level lapse rates. So we want to check really how quickly temperatures are decreasing at the lowest altitude. So specifically around the surface to about 1.5 kilometers above. So again, this is measured in Celsius per kilometer, just like all lapse rates in general. So what we're looking for are these brighter colors, which we're already seeing. So this makes sense. This is the afternoon of July 12th, so this afternoon. And we're seeing these bright colors, which represent rates of about 8 to 9 degrees Celsius per kilometer. So this is really, really steep. And this will help to improve instability. Going to the late afternoon, mid to late afternoon, we're still seeing those brighter colors still with us, and you're still seeing them into the late afternoon to early evening, which is pretty steep for these hours. Okay, so this is showing us surface moisture convergence represented in grams per kilogram per second. So this just gives us an evaluation of how strong our frontal boundaries are. So this is a situation where we're seeing these stronger areas of convergence that are taking place ahead of our warm fronts. As I mentioned before, we have a warm front at play for July 12th. So this is the mid-afternoon of July 12th, 2 p.m. today, July 12th. So let's go further into July 12th, and you're starting to see this area of maximized lift taking place ahead of our warm front. So this is something to watch, I think, for the mid-afternoon period. This is progged for 5 p.m. today, July 12th, Eastern Time, and also into the late afternoon period where we're seeing this situation. This is 8 p.m. now, and we're seeing these areas of enhanced coloring. So these more representative areas of higher lift ahead of that warm front that are taking place in Eastern Ontario, Southern Quebec. So I think this is a place to really, really watch. Okay, and now for the case of July 13th, where the cold front becomes more important. We're actually seeing, again, this area of maximized lift taking place by late morning of July 13th. So the late morning of July 13th, we're seeing this area of maximized lift as represented by these brighter colors. And into the afternoon, so this is now mid-afternoon, 2 p.m., we're still seeing that effect taking place across not just southern Quebec, but also Eastern Ontario and portions of the Northeast. And again, by 5 p.m., you're still seeing that persisting. So really, throughout the afternoon, you're seeing this heightened area of convergence ahead of that cold front and into the late afternoon period as well. So I think this is something that's important to watch. Again, our mid-level lapse rates are still very modest, so that is putting a lid on particularly high instability, but we do have still very high amounts of instability to work with and some pretty good lift, I think, in the case of July 12th, the warm front, and July 13th, now the cold front. So something else I'd like to bring your attention to are shortwave troughs, any potential shortwave troughs. So one way to evaluate that is the 500 millibar altitude. So that's where these events or these features tend to take place. So what we are looking for are heightened areas of vertical velocity at these altitudes. So Again, you're just looking for those brighter colors. That represents the highest amounts of lift. And you're actually seeing these subtle zones starting to emerge in upstate New York into southern Quebec. And let's go further. This is 2 p.m. Let's go deeper into the afternoon. So now 5 p.m. and you're seeing these blobs that are appearing right along the New York border. So this could actually serve as an initiation zone this afternoon for some strong thunderstorms, I would think, in this zone, and potentially affect the Montreal area, since these thunderstorms would be allowed to propel themselves to the northeast. So this will be something to watch. And just out of curiosity, let's go further into the afternoon. And yeah, you're still seeing these localized pockets of maximized lift that are taking place, indicating a subtle shortwave trough in this area that is acting to boost these localized areas of lift. So this afternoon, I think, would be something to monitor. And then going into July 13th, so this is the morning of July 13th, but let's go further later into the afternoon, or later into the morning and now into the mid-afternoon. So you're seeing this broader area of maximized lift. So remember, we have that cold front that is already maximizing lift at the surface, but you're also having the shortwave trough that's joining forces with it to amplify the amount of lift. So this is suggesting to me a situation where we could have scattered to widespread thunderstorms in the case of July 13th, whereas on the July 12th, during the mid to late afternoon period, there would be at least scattered coverage, I think. So scattered coverage for July 12th, and for July 13th, I expect more widespread coverage, scattered to widespread during the afternoon period. And a lot of these thunderstorms can reach strong to severe status. Okay, so looking at our dew point temperature, which is a representation of how much humidity is in the air. So we're actually seeing some really high amounts of humidity taking place in Eastern Ontario, Southern Quebec. This is for July 12th. And the humidity is very high, as represented by a dew point of 72 Fahrenheit, which is in the early 20s Celsius. So these represent very high humidity zones. So this will also amplify instability. And then going to July 13th, we're pretty much seeing the same thing throughout the afternoon. This is the mid-afternoon July 13th, just to give you an idea. Okay, so looking at the amount of CAPE, so this is convective available potential energy. It's a gauge of how much energy is actually present in the atmosphere. So it's a function of how quickly temperatures are decreasing with increasing altitude, as well as how much moistening is taking place at and near the surface. So as you might recall, we don't have that much in the way of mid-level lapse rates, but we do have strong low-level lapse rates and very high humidity. So that is still sending these CAPE values to almost 2,500 joules per kilogram. This is the mid-afternoon of July 12th. And remember, we have that warm front that's also exercising the amount of lift that's taking place. So that would take advantage, I'm thinking, along those subtle zones of lift, and also that shortwave trough that I mentioned that's creating these localized areas of maximized lift, as we saw. So now we are into the morning of July 13th and now afternoon of July 13th. So again, our mid-level lapse rates are pretty limited, but we're still seeing CAPE values nearing 2,500, possibly even 3,000 joules per kilogram, despite the absence of steeper mid-level rates. But we still have strong low-level lapse rates, and we have strong moistening, and I think that's still helping to amplify that instability factor. And remember, we have a huge amount of lift that's taking place here. So I'd still expect many thunderstorms to erupt in this zone, from particularly the southwestern portion of New York and going northeast towards all the way up to Quebec City. So this zone, I think, will be a very important place to watch for tomorrow. Okay, so this is a skew-T log P diagram for the west end of Montreal. So that's our sample area. So this is 2 p.m. July 13th. So I just decided to zoom straight to the afternoon of July 13th just to get an idea of what the environment looks like in large part, and sort of summarizing what we looked at before. So we have a large amount of CAPE, as represented by this gap that's taking place over a large tropospheric depth from near the surface all the way up past the tropopause. So I do expect some pretty explosive thunderstorm development taking place here. Some very robust updrafts would be present in this sort of environment. We also have some dry mid-level air. So this is the 500 millibar altitude. So this represents approximately the a portion of the mid-altitudes. And we're seeing this drying effect taking place, as represented by this rapidly or fairly rapidly decreasing dew point temperature or moistening effect that's taking place around the mid-altitude. So this, I think, will help to improve the chance for some locally strong downbursts with some of these thunderstorms that do form, the families of thunderstorms that actually form with this situation. Now, the 500 millibar altitude, so if we just shift our attention briefly to that, and we follow this diagonally down, because that's how you interpret these plots. So this is our environmental temperature. So let's come down from 500 millibars all the way down to the surface, which is about here, and we see a temperature of about, let's say, -7 to -8 Celsius. So we do, as I showed before, the mid-level lapse rates are not particularly steep. I mean, they're not steep really at all, but we do have a pretty good mid-level temperature as taking place here to encourage hail production and also amplify the risk for locally strong downbursts. Now, I think the limiting factor would be these wind shear profiles. So we're not seeing a particularly defined shearing profile that's taking place here. It's mostly unidirectional. So I think this will help to reduce at least the tornado risk, although there is a chance for embedded supercells within some of these thunderstorms, especially early in the period before more aggressive thunderstorm consolidations occur. So I wouldn't rule out a weak tornado early in the forecast period, especially early in the afternoon as we're seeing here. But in general, this does suggest mostly a straight line wind hazard with the orientation of these southwesterly wind profiles that are taking place. And we're not getting a particularly huge amount of speed shear. So these thunderstorms, I don't think will be moving all that quickly, but I think this will help to encourage, based on the overall environment, from very high humidity to somewhat limited shearing profiles. I think this will help to encourage mostly a flash flood risk. So significant water accumulation with the thunderstorm families that erupt, especially since, as I mentioned, the lift is strong enough to promote many thunderstorms altogether. So these will be capable of locally flash flooding, a locally flash flooding hazard. Okay, so this is a SKU-T log P diagram for July 12th. So I'm just backtracking to July 12th since we just looked at July 13th. But July 12th also has a prominent risk, as I mentioned, because of those localized areas of lift that are taking place in and around the Montreal area. So this is for the Montreal area, the west end of the Montreal area anyway. And so you're seeing this large amount of instability that's taking place, this similarly distributed like July 13th, and also some very weak, even weaker shearing profiles. So I don't expect thunderstorms to be particularly long-lived in this situation, although they have that potential to be severe temporarily in the Montreal area, and around the Montreal area. So this will be something to watch altogether. And they will be slow moving. So again, much like July 13th, and probably more so for July 12th, is that the hazard would be mostly localized flooding with some of these thunderstorms due to the heavy rainfall rates in light of our very high humidity factor. Hail will also be very possible, especially because we still have a fairly cool 500 millibar temperature, and we also have a strong drawing effect as represented by our rapidly steepening dew points. So at the mid altitudes, we do have some fairly steep drying that's taking place, and I think this will improve the hail production as well as locally strong downbursts when these thunderstorms are in their most mature state. Okay, so just as a summary of where I expect thunderstorms to form, so in the case of July 12th, I expect them to take place in roughly this area, so roughly around the Montreal area and going into neighboring Eastern Ontario. So again, I don't expect too many of them to appear, mostly in isolated to scattered. It's hard to go beyond that since our lift is very localized. So I expect thunderstorms to be mostly isolated in coverage ahead of that warm front and that subtle shortwave trough that's taking place in the zone. Now, again, the primary hazards would be intense lightning and some small hail, as well as locally strong downbursts. Now, these hazards will be very temporarily sustained, so it's nothing too significant altogether, and these thunderstorms themselves will be short-lived since our wind shear profiles are fairly similar. But for July 13th, I expect a broader sort of zone because of much stronger lift that's taking place with the cold front now. So in July 12th, it's the warm front plus a shortwave trough. In the case of July 13th, it's a cold front with a potent shortwave trough. So we're seeing this area of maximized lift taking place over a broader area. So I expect at least scattered coverage in this zone. Now, I don't expect thunderstorms to be particularly severe overall because of that shearing factor, the wind shear factor that is more limited. So it doesn't mean that thunderstorms won't be severe, but there will be quite a few of them that will reach strong to severe status, but they will have more difficulty sustaining that effort. Nevertheless, during the time of maturity, especially farther west in that zone, in this redder zone, I think the thunderstorms will still be capable of locally damaging winds, at least temporarily again, locally small hail, and there will be a window of opportunity for an isolated weak tornado to form before more aggressive cell consolidations take place. In other words, when thunderstorms start to merge more aggressively. So that will be an opportunity, I think, especially in eastern Ontario and western New York and central New York. At the same time, in both cases of July 12th and July 13th, I do expect lightning frequency to adopt at least a moderate sort of frequency, even high, temporarily. Thank you very much for making it this far and listening so attentively. I really appreciate your viewership. And if you like this video, if you found it intuitive, if you would like to see more videos like this in terms of forecasts and just thunderstorm documentation altogether, not just from the Montreal area, but also from the Florida area, the Orlando, Florida area, feel free to subscribe so you do not miss out on upcoming videos. And also, just as a little extension of this forecast, this zone around the Montreal area stands a chance for a heat wave, even potentially a significant heat wave, if these days in question cooperate enough. So many of these areas will be facing high heat and humidity, but the Montreal area stands a chance for a technical heat wave since we did strike over 30 degrees yesterday, and the next few days threatening to do 30 degrees Celsius again. So this could create a technical heat wave for this area.